In this video, we're going to take a look at exam revision for fractions. So all we're going to do here is just take a look at some exam style questions for fractions. What I would say is pause the video, have a look at the questions as they appear, and double check that your solution matches what we get on the screen. So other than that, that's everything that we need here, so let's get started with question 1. So we begin here with part A. We're asked to work out 1 over 4 plus 2 over 5. Let's just write that down to begin with. We've got 1 over 4 plus 2 over 5. What we're doing here is addition of fractions, but before we can add fractions here, we need a common denominator. So 4 and 5 aren't common denominators, so in this case we need to get a common denominator, and the easy way to do that is to times this fraction here by 5, the opposite denominator, times this one here by 5, and we're going to times this fraction here, the second fraction, by the opposite denominator. In this case it would be 4. Times this one here by 4. So in that case then, make sure you times both the numerator and denominator by this number here. So 1 times by 5 would give me 5. And 4 times by 5 would give me 20. So we get 5 over 20 to begin with. Doing the same now with this fraction here, 2 times 4 would give me 8. And then 5 times 4 gives me 20. And what we notice here straight away is we now have a common denominator, so we can now add the fractions together. When you're adding fractions together, remember we only add the numerators together here. I'm going to get 5 plus 8 over 20. So 5 plus 8 over 20. And 5 plus 8 is 13. So we get 13 over 20 there. Okay. And there we have it. So 13 over 20. And that's the solution to A there. Taking a look at B now. So we're asked to show that 5 and 2/3 minus 1 over 2 is equal to 5 and 1 over 6. So let's just write that down to begin with. So 5 and 2/3 minus 1 over 2 is equal to 5 and 1 over 6. So to begin with here, what I need to do is take this mixed number here, this 5 and 2 over 3, and change that into an improper fraction. Remember to convert from a mixed number to an improper fraction, quite straightforward. All we do here is we take the integer, the whole number, and we times that by the denominator. So 5 times 3 is 15. And then we add on this number here, the numerator. That's going to give me 17. And we keep the same denominator here. So I get 17 over 3 minus 1 over 2. Okay. What I've got now is a straightforward subtraction here. But again, just like addition, we also need a common denominator here. So in this case, what I'm going to do is times this fraction here by the opposite denominator. I'm going to times this fraction here by 2. And we times this fraction here again by the opposite denominator. So I'm going to times it by 3. In this case here then, make sure again that you times both the numerator and denominator by this number here and here. So 17 times 2, that would give me 34. We get 34 there as a numerator. 3 times 2 would give me 6. We get 34 over 6 there for the first fraction. Doing the same now with this fraction here. So 1 times 3 would give me 3. 2 times 3 would give me 6. And now, because we have a common denominator here, we can perform the subtraction. I get 34 minus 3 all over 6. And in that case, I'm going to get 31 over 6 there. Okay, but we're not done here because the question states that we should show that this is equal to 5 and 1 over 6. What we need to do now is take our improper fraction here and convert that into a mixed number. So 31 over 6, so what we're checking here is how many 6's go into 31. Well, in that case, that would be 5. 5 times 6 is 30. We're going to get 5 there. So what's the remainder then? So 31 is what we need to get to. So 5 times 6 is 30, so that means the remainder is 1. That gives me the numerator there. And our denominator here is the same as what we're working with here. I get 5 and 1 over 6. That's required there. Okay. And there we have it. So that's the solution there to B. And that's the solution to question 1. Moving on to question 2 now. Again, we've got 2 parts here, so let's begin with part A. We're asked to work out 2 over 3 times 3 over 4. What we're doing here is multiplying fractions together. So let's just start by writing down the multiplication. So 2 over 3 times 3 over 4. So just remember here, when we're multiplying fractions, we multiply the numerators together. I'm going to get 2 times 3 here for my new numerator. Then for my new denominator here, we just repeat that process. So it's going to be 3 times 4. Okay. So let's evaluate the numerator first. So 2 times 3, that would give us 6. 3 times 4, that would give us 12. We get 6 over 12, and we can leave our answer like that. That would be fine. It doesn't ask for it in its simplest form, but if we do simplify this here, this would be 1 over 2. Okay, so we get a half there. That's the solution to A. For B now, we have to work out 3 over 5 divided by 1 over 2. So again, let's just start by writing down this division. So 3 over 5 divided by 1 over 2. So how do we do division of fractions here? Well, the way that I like to remember for division of fractions is K, C, F. Okay. This tells us that we keep the first fraction. So we keep the 3 over 5. Let me just do this underneath. So we keep the 3 over 5. We now change, so the C here tells us that we change the division to be a times. And then we flip the second fraction here. So rather than it being 1 over 2, now it becomes 2 over 1. And now what we do here is we just perform this multiplication here, just like we saw for part A. So 3 times 2 is our numerator, like so. Then 5 times 1 here for the denominator. But in this case here, what we're going to get is 3 times 2, which is 6, over 5 times 1, which is 5. So we get 6 over 5 here. Now, the question doesn't ask this improper fraction here to be given as a mixed number. So what I would recommend here is just leave your answer like this, okay? Don't bother wasting time changing this now to a mixed number, unless you want a bit of extra practice, which obviously is fine for this question. But in an exam, like I said, if it doesn't ask for it as a mixed number, I just leave your solution like this, okay? But there we have it. So that's the solution to A, the solution to B, and the solution to question 2. Moving on to question 3 now. So again, we've got 2 parts here. So let's begin with part A. So for part A, we have to work out this bracket here of 5 over 8 minus 1 over 4, and then we times it by 2 over 3. So as we begin with here, let's just write down this expression. I've got 5 over 8. And minus 1 over 4, I'll subtract 1 over 4 from that. Then we times this bracket here by 2 over 3. So for this part here, part A, we actually need to use BIDMaths, okay? So what I've got here is brackets. So let's evaluate the brackets first. So I've got 5 over 8 minus 1 over 4. So we're doing subtraction here of these fractions. But again, we need a common denominator before we can perform the subtraction. So what I can do here is I can times this second fraction here by 2. That would give us a common denominator here of 8. What I'm going to get here then is 5 over 8 minus 2 over 8. So times in both the numerator and denominator here by 2. So 1 times 2 would give me 2. 4 times 2 would give me the 8. And we times this here by 2 over 3. So now if we had to perform the subtraction here, 5 over 8 minus 2 over 8, that would give us 3 over 8. So what we get here then is 3 over 8. And then we times that by 2 over 3. Okay. So now what we're doing here is multiplying these fractions together. Remember, we multiply the numerators together. So I'm going to get 3 times 2. It will all be over 8 times 3. Well, 3 times 2 is 6. We get 6 there for the numerator. For the denominator now, 8 times 3 would give us 24. We get 6 over 24. And it doesn't ask for it in its simplest form, so we could leave the solution like that. But we do want to simplify this here. 6 over 24, that's the same as 1 over 4. Okay? We get 1 over 4 there. And there we have it. So that's the solution to A. If we take a look at B now, we have to work out 3 and 1 over 3 times 2 and 1 over 6. And here we want to give the answer as a mixed number in its simplest form. Let's just start by writing down this multiplication here. We've got 3 and 1 over 3 times 2 and 1 over 6. Okay? So here, because I've got two mixed numbers, I've got this mixed number here and this mixed number here. Before we can do any multiplication, we need to change these mixed numbers to improper fractions. So 3 and 1 over 3. Remember, converting from a mixed number to an improper fraction, we start by taking the whole number here and timing it by the denominator. So 3 times 3 is 9. Plus now the numerator, that would give me 10 over 3. I get 10 over 3 there. Then we times this here by 2 and 1 over 6. So again, we need to convert this now. So again, we take the whole number here, 2, times it by the denominator. So 2 times 6 is 12. Add on the numerator now, so that would give me 13 over 6. And from here now, because we're multiplying, we can just perform the multiplication. So multiplying the numerators together, we get 10 times 13. That will all be over 3 times 6. So 10 times 13, that would give me 130. And then 3 times 6 would give me 18. But we're not done here, because we need to give this answer as a mixed number in its simplest form. What I need to think about here now is how many 18s go into 130. Well, what I think about straight away here is that if I do 18 times 5, that would give me 90. Okay, so that would give me 90. So in that case then, we're 40 off 130. But what I also recognize as well is 18 times 2 is 36. Okay, so in that case then, if I do 18 times 7, that would give me what I need here. So the whole number here would be 7. If you think about going up in the 18 times table, I know that sounds a bit silly, but the 18 times table here, well, it would go in 7 times. So that would leave me with 126 there, 90 plus 36. That would give me 126. So in that case then, we need to think about the remainder here. Okay, we've got 126, we need 130. The remainder here would be 4. And our denominator here stays the same. It's going to be 7 and 4 over 18. But again, we're not quite done here because now this is in its simplest form because we can simplify 4 over 18. So this would be given as 7 and 2 over 9 there. Okay? And there we have it. So that would be a mixed number in its simplest form there, giving us the solution to B and the solution to question 3. And finally, we finish with the very last question here. Question 4, we're asked to work out 2 and 1 over 4 divided by 1 over 3, giving our answer as a mixed number in its simplest form. So again, because we've got a mixed number here, we need to convert this now to an improper fraction. Let's just start by writing down this division here. We've got 2 and 1 over 4 divided by 1 over 3. So changing this here to an improper fraction, we take the whole number, the 2, times it by the denominator, which is 4. So 2 times 4 is 8. Add on the numerator now. I'm going to get 9 over 4. We get 9 over 4 divided by 1 over 3. Okay. So in this case now, because we're dividing fractions here, we use KCF. This tells us that we keep the first fraction. We keep the 9 over 4 as it is. We now change this division here to be a multiplication or a times. Then we flip the second fraction here. So rather than it being 1 over 3, it now becomes 3 over 1, like so. And now what we do here is we just perform the multiplication. So 9 times 3 is our numerator. And then for the denominator here, it's going to be 4 times 1. So 9 times 3 is 27. 4 times 1 is 4. We get 27 over 4 here. So we're not done here because we need to give this now as a mixed number in its simplest form. So how many 4s go into 27? Well, I could do 6 times 4, 6, 12, 18, 24. So that would give me 6 there for the whole number. Now, what's the remainder here? So like we said, 6 times 4 is 24. So that means we now got a remainder of 3 here. Now our denominator then would be 4. We keep the same denominator. And there we have it. We can't simplify this any further, so it's already in its simplest form. And it's now given as a mixed number. So there we have it. That's the solution there to question 4. And that brings us to the end of this video on exam revision for fractions. In the next video, we're going to take a look at an introduction to estimation.